first install the Arduino IDE, it only comes with ARM processor support, and we need to load support for ESP. Go to File, Preferences, and open the dialog. Turn on verbose compilation so that we get more lengthy error messages during compile, and paste in the URL that gives us ESP8266 processor support. That's in the project notes. Then go up to Tools, and you should now see that through Boards Manager, if you enter ESP, that we've now got support for the ESP processors. You need to select version 2.7.4. This is the highest level version that I've tested and works. There are other versions available, but version 3 onwards does not work with this project. Once that's done, close out. We also need a means to send data files to the ESP. Now, there's no menu option initially to do this, so what we need to do is load an add-in. You pull the add-in from this website. Click on the zip link and that will download it to your downloads folder. Then navigate into that folder and double click it to open it. Then we need to create a tools folder underneath the Arduino folder and then drag that add-in into the tools folder so that you end up with Arduino tools, ESP add-in, tool, and then the actual jar file itself. Then close the Arduino IDE. This forces it to reload the tool. Go back in and you'll see that we now have a menu option to send or publish server files. We now also need to select the actual board that we intend to use. So in this case it's the Wemos D1, and you can see that that board has been loaded now. Now we need to download some external libraries for this project, which we will pull mostly from Github. First one here is ESPAsyncTCP. So go through, click on the link to the repository, then click on the green code icon and click download zip. And it's the same routine as before. So the file will download into the downloads folder. We can open it to expand it, and then we need to drag this file into the Arduino library. So that's the libraries folder that sits under the Arduino folder. You then drag this repository folder across to it and rename it to remove the -master ending from it. Next up is the New-LiquidCrystal repository. So same principle, click on the green code icon and download the zip. Once that's downloaded, expand the folder and drag New-LiquidCrystal across into the Arduino libraries folder and remove the master ending. We need one more repository. This one is not actually GitHub, it's a different external URL with a whole history of different versions, but the version that we want is 5.13, i.e. the last of the version 5. Version 6 does not work with this project, so use the last of the version 5s, download that, expand it, and again drag that folder across. There's no need to rename it because it doesn't have any master ending on it. We need two more libraries, and these are pulled from the Arduino library manager. So one of them is the INA219 library. Enter that in the search, scroll through, and it's the Adafruit one. I'm using version 1.1.1, I think it is. That works with the project. Other versions may well work, but I haven't tested them. and install that. And then we also want WebSockets by Marcus Statler. So there's a number of WebSocket libraries in here, but the one we want is the one from Marcus, and use the latest version of that one. Again, click on install. Now we're ready to download the actual ESP DCC controller project itself. This again is on GitHub. So click on the green code button, hit download zip, pull that into your downloads and open it. Double click on the zip folder and then pull the contents of that into the Arduino folder. So this is actually a project. Remove the -main off the back of it and open it up, and double click on the INO file to open it within Arduino. And one last check is to make sure that we've still got the correct board selected that we wanted, so the WeMOS D1 in this case. This project supports quite a lot of different hardware options. These are controlled through the Global.h file. In there you'll find references to generic variables, but the thing that controls the board configurations is this section here. To disable an entry, just put an N in front of it, and to enable an entry, remove that N or add a new definition. So for this particular example with the two board controller, that's the WeMOS D1 and L298. That's defined further down the list. If you wanted to disable that, you just put an N in front of it, and then perhaps you might say want to enable the other option, which is using a node MCU and a do-it shield. But that's not what we're doing here, so let's go back and enable the WeMOS option. And then we'll scroll down and actually look at that section in more detail. Okay, so this is the section in question. The first bit of it is just some text describing what the various pinouts are, mapping the GPIOs to the Arduino D port notations. And then under that there's a section that deals with analog current measurement is dealt with in this section. So for this particular project we're using the onboard analog to digital converter, and we're using the A and B channel common together, so there's a correction factor that's handled in this section here. As an alternative, you could disable analog current measurement if you were using an INA219, for example, so you would just type an N in front of it, but we want to retain it. The next section talks about the actual pin configurations for the DCC signal. There are two channels, therefore there are 4 pins that we need to configure. So these are the GPIOs that map into those pins. And then there's another section that follows on that maps all the I2C bus pins to the GPIOs as well. And lastly, there's a couple of sections. One relates to the LCD device. So again, if you've got an LCD display that's hooked up to the I2C bus, you can configure the pinouts on it here. These vary with the different backpacks that are connected, and the particular backpack I have is this Y robot backpack. So those are the pinouts that are required for that. And the final section here, which actually is not part of the board configurator but is again global to the whole project, is trace messages, which you can enable. Now it's time to compile, so click on the tick icon and you'll see the verbose compiler messages piling up. So we've put all the libraries in, we don't expect to hit any errors. Okay, it's done compiling, so that was successful. Next thing to do is to actually upload it to the hardware. So you do that through the tools menu and check that you've got the correct COM port set up, and then you press the arrow, which recompiles the project, but this time it will actually upload it to the board when it's done. Well, it's quite a fast process with the newer versions in Board Manager. And once it's finished uploading the main program, we need to send up the data files, which are the HTML pages. So we invoke the menu option to do that. The system then sends those up. Takes a few moments. And it's done. Okay, now we're ready to monitor or boot the system up and monitor it through the COM port. So with it still hooked up, press the reset button and you'll see some startup messages. Then what you need to do is navigate on your mobile phone to DCC ESP and connect. Then what you'll see back in the Arduino IDE is a message saying that a client has connected, and similarly if you disconnect that client by changing the SSID, then you'll see a message saying that it's disconnected. Thanks for watching. If you found this useful, hit subscribe.